Ah, let me in. Oh yeah, have it. Come back, bro. That was fun. Ooh, ooh, ooh. I maybe shouldn't have enjoyed that as much as I did. Okay, guys. So, if we can kind of get past that moment of homicidal glee. Welcome to a security port goddess that I made. That moment of manic laughter didn't happen. Also, got a new mic, so I'm hoping this sounds a lot better and doesn't have the buzzing that I had in previous videos. Okay, so this whole setup here comes from the security door that I made in a previous video, and I was working on a design for a castle, which I think looks kind of okay. And what I wanted to do was I wanted to make it so that if I had a portcullis like this where monsters could quite easily sit, they would automatically be killed if they sort of came within range of it. So the whole idea of this as well is that it opens automatically when you walk towards it, but if there's no player in there and there's monsters, then it will set off a trigger and kill them, as you saw, without any crazy laughter. Okay, so the way that all of this works is very much like the original security door, except for what it's got on the side here, as you can see, are these dispensers with a setup that fires them off very quickly. So what I'm going to quickly do is quickly show you how that is done there. So the way those comparator sort of very quick ticking things work is that if you put a comparator here and set it to subtractor, when you have a signal coming in from the back and you do this, it flashes like this constantly, and you're not going to have the flash sort of break because of the torch sort of running out or anything like that, burning out. And the way it essentially works is it subtracts this from here, and when it's subtracting the amount that obviously takes that down to 0, well, then it's subtracting 0, so it lets the power go out, then it's subtracting enough to make it go down to 0, then the power goes up, and that happens very, very quickly. And all it's got running off of that is something like that. I'll turn that off because it's pretty damn annoying. Right, so that's how that comparator thing works there, and that might be something you want to use in all sorts of things within Minecraft. Okay, so the way the actual program works, if you don't remember from one of the previous videos, if you've got something that's running, press Ctrl-T, terminate the program. So if I go into Edit Startup, and once again, if you have a program called Startup, it will run automatically when the computer turns on. So if the computer was running it or it wasn't on, you start up the game. When it starts running again, it will start up with this program, or if you just click on the computer, it will start running this program. Okay, so I don't want to make this too convoluted. I want to make it quite concise so you can see what's going on. I did cover this in one of my previous videos, but I'm also going to recover it again because I got asked to put those codes up as a Pastebin with a sort of generic use for them. So what I'm going to do is I'm going to alter them and put them on Pastebin so that you can use them. And you can see here, just looking down here, is I've commented this out and it says these are things to change for yourself, and these are all the variables you can change. Okay, so starting off, we've got at the top here is the os.load_API, and this sentence in here. This loads up your sensor information. This just allows you to use sensors. If we look on top of here, we have a sensor, and if we look inside, I've got a proximity sensor card. I think that might be a creative one, but the lower one will work. Okay, so here we have, I've defined a variable called mySensor, And I've made that basically a peripheral. This is the sensor equivalent of a peripheral. I'm just wrapping it to the top. So it means that whenever I call my sensor, I'm calling the sensor that's at the top. I've got another variable here. Well, I've got 3 variables here that we don't change. I've got player equals false, monster equals false, and position equals an empty table. The reason I've put these here is I don't like having the computer create a variable, then remove a variable, create a variable, remove a variable. And we would have to create these variables each time because we're using a while loop below. That's just an old thing. I don't know if Lau's okay with that or Computer Craft is okay with that, but when I sort of learnt to code, it was you have to sort of make sure you get rid of that memory that's being used. So it's an old hangover. You don't necessarily need to do that. I just do it just to be safe. And then below that, we've got a set of variables. Now, this will be paste-binned up. This door direction right should be fairly self-explanatory. Is you can change that text of right there to whatever direction you want coming out of the computer. And what that controls is the door down here, as you can see. In the previous security door thing that I did, you would have to invert it so that if you wanted to have the door open, you set the code saying turn power off. What I've done on this one is I've inverted and then inverted again. So we've got the power coming out here. It's inverted by this redstone torch and then sort of set back to what it is by this one below. So basically when the power is coming out of here and can turn this torch off, that door will be open. And when there's no power, the door will be closed. And it's the same with the dispenser direction. As you can see, it's set to back. What happens here is it comes out. I just use a repeater here just to make sure there's enough power to go all the way to the end there. Probably would go fine without it, but best to be safe. And it's just exactly the same thing that I showed over there. Is power comes in, it's set to subtract. Because it's subtracting, it will constantly take it down to 0, up again, down to 0, up again. And that just powers these dispensers at the back here. And so whenever there is a signal being sent out there, these dispensers will be firing. Now, these final ones here I will come to in a second. I'm going to take you quickly through the while loop. So at the start of the while loop, we set player and monster to false as default. After we set those player and monster to false, we do a os.sleep command here. What that is for is just to make sure this while loop isn't going through too many times, because you don't really need it going too quickly and you don't really want to use up too many resources, especially on your own computer or if you're on a server. You don't want to be having that loop going through as quickly as it can. Every half a second is perfectly fine. Then we have a for loop which pulls out these sensor targets that mob or NPC or player detector comes up with. And it pulls it out in pairs, so we get a key and a value. So we get pairs of keys and values, and we get sort of a whole load of them. What we do on the first if is to say, okay, for any given v, for any given key, is v, the value, not equal to nothing? So is there a value in there? And excuse me a second, it's going to nighttime. Don't want anything spawning. Okay, and then I set is v a player? If v is a player, then we pull out the position table from v. Now, if you didn't see the original video that I did on this, when you get these information from sensor, get targets or get target details, what happens is you get tables within tables. So each label can either refer to a value or it can refer to a table. In this case here, position refers to a table that has further values inside it of x, y, and z. Now this is where the next set of variables come in. What we have here is y max, y min, x max, x min, z max, z min. What this is the values in which an entity has to be present for it to trigger whatever it's referring to. Now, these are also in relation to the actual sensor itself. So you'll notice here that y min is -2. And the reason for that is if this sensor of y is at 0, well, this block we're standing on here is actually y is -1, and let's get up to how we use it. And where I just placed that wall block, well, that would be -2. So that'd be -2, -1, 0. Go up 1. I can get it. There we go. That would be 1. So if we go down here, we say, and we have a look here. So okay, is the position for this entity greater than the minimum x and less than the maximum x? Is it greater than the minimum y and less than the maximum y? So y is like that, and you can really only be on a block like that or you're jumping. So the reason that we have y, go back here, as greater than -2, well, that means that it's on -1 or above, which is the block we're standing on at the moment. And less than 1 means it's either between -1 or 0, which means it could be standing there or it could be jumping. And that's just in case sort of monsters get moved around or you jump when you're going towards it. The x max and the x min is exactly the same. It goes off of the global coordinates in relation to the sensor. So I've just pulled up here the debug screen. And if you look at the top left, as you can see, we're on an x of 817. If we move to the left one like this, we can see it goes down to 816. So this would be the negative direction, and this would be considered as 0 by that sensor. If we go left 1 and left 2, well, that's -2, and that's sort of the edge of here. So we want to be greater than -2, and then the same thing here, 0, 1, 2, 3. Well, this here, nothing can be there. We want it less than 3 and greater than -2. So if we go and have a look here, same thing. And for the z, it's the same thing. So z here, well, that would be a z of 0, -1, -2, -3, -4. So we want it less than -4, -5, -6, -7. But the line of -7 is the actual line between these two blocks. So we want it greater than -7 and less than -4. So anything within this range of values, as you can see, we will say player is equal to true. If I save this and run it again, you'll see that when I walk outside here, of this line, in, but it doesn't open when you walk here. And the reason for that is obviously you don't want to walk up to the door if there's monsters out there and have a creeper blow up in the face. Of course, you want these little grills here. You can still see stuff getting killed. I mean, make sure nothing's there. Okay, so now the next thing that we do is we do the same thing, except for we find if it's a monster. Now, potentially what we could do here is just say if v is not equal to nil, and then say, okay, well, if v is not equal to nil, put out a position. If the position is this, then if it is a player, do this. If it's a monster, done this. I've just done it this way because this runs off of the same sort of coding that I did for the original one. Okay, so once we've defined whether or not there's a monster or a player, or a monster and a player potentially, or neither, within these zones that we set out, we come out of the for loop. So we've now checked everything, and then we say, okay, well, if the player is equal to true, set the redstone signal direction out to 15 in the direction that we say. So we're going to set the redstone to a strength of 15 in right with our variable that we've got there, because we use door direction. And if there isn't a player there, set it to 0. Now, we don't really need if monster equals true and player equals false, but it's once again, this was just put here so you can easily see what's going on. We say, okay, if there's a monster there and there's a player, there's not a player there, then we set out a dispenser direction, which as we know is currently as back. We set as power 15. Otherwise, any other situation, set it to 0. So this means that this door will open whenever there's a player within this area here. And if there isn't a player within this area here and there is a monster, those dispensers will fire off. Obviously, we don't want the dispensers firing off when there's a player there. And I totally didn't die the first time testing it out. Just saying. So there you go. That is sort of the rundown of how this works. Like I said, I didn't really want to waffle too much in this video. I have done this before, and I am going to be doing another video that sort of explains the original code that this came from. This will be paste-binned up. I'm just going to give you another demonstration of it working. So we save, exit, run startup. Take this screen off. Set up to easy. Grab a spawn egg. We're not in there at the moment. Undead creeper. And then if I put a spawn egg here while I'm here, as you see, nothing happens. And it gets killed the minute you walk out of range. There you go. Okay guys, so I hope you enjoyed that video. I hope you find it useful. Please do leave me a comment or feedback, whether it's positive or negative. Any questions, let me know. Feel free to give the video a like, and yeah, catch you soon. And I just want to point this out again, that wasn't a creepy laugh and joy I had from killing creepers. Bye!